right. Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is solving quadratic equations with square roots, as in you have to solve it by taking a square root. You don't have to use a square root. You could also factor it, depending on what form it's in, but you know you have to factor when there's more than one kind of x. Okay, so keep that in mind. That's like the key to knowing when to factor and when to just solve it normally. Like add or subtract something on both sides of the equation, and then multiply or divide something on both sides, like that kind of thing. Like two-step equations, one-step equations. That's like the normal way, right? The normal way. And then you have like the factoring way. So normal way versus the factoring way. You might have to factor. Normal way, you have like x, or maybe an x squared, or any kind of power of x. It could be x cubed, it could be the square root of x, anything like that. That's the normal way. Factor way would be if you have like x squared plus x, or x cubed plus 2x squared, or anything like that where you have more than one kind of x. You know you have to factor if you have more than one kind of x. You might still be able to factor if there's not more than one kind of x, but you only need to factor the equation to solve it if there's more than one kind of x. So with these problems, what I'm going to do is I'm going to do it exactly how they're saying, with square roots, right? Square roots. We're going to do a square root. When you do a square root, you have to remember that the answer is plus and minus. So let's look at this. In order to solve this, I need to get k by itself, right? When we say solve, we mean like get the letter by itself. That's like at its core what you're doing. So the only reason why k is not by itself is because of that 2. The 2 is the power. It's a square. I can't divide by 2 to get rid of it because it's not timesing by 2. The opposite of powers is not dividing. So don't do dividing when you see powers. Be careful with that. You want to do a square root to get rid of a power of 2. If it was a power of 3, you would take a cube root. Power of 4, take a fourth root. They cancel each other out that way. So anyways, we take the square root, and now we have k. The square root of k squared is just k. All right, they cancel each other out. They're opposite operations, like adding 2 and subtracting 2. Timesing by 2 and dividing by 2. Powering by 2, rooting by 2. And then we need the square root plus or minus, that is, plus or minus the square root of 76. Okay. And this factors. This factors because if I divide it by, not factors. Well, yes, factoring, but not like maybe how you're thinking. It looks like it divides by 4. And I know that because let's say we added 4. If we added 4, we'd get exactly 80, and I know 80 divides by 4. So 76 must divide by 4. And of course, I'm going to assume also in this worksheet that you don't have access to a calculator, or you're not allowed to. Let's say you're not allowed to, right? Well, if you're not allowed to use a calculator, you have to do it by hand, right? So we have to figure out how to do this. Let's say 4, and that would go in once, and then 4, 3, 36. That goes in 9 times. So, excuse me, 19. Now, the trick with that is, the other thing you could do is, you know how I was saying if you add 4 to 76, you get 80? Well, 80 divided by 4 is a little easier to do in your head. 80 divided by 4, 8 divided by 4 is 2, and then add the 0, it would be 20. Well, we had to add 4 to get to 80, so it would be 1 less than 20 would be the answer, 19, right? So if that made sense, awesome. If not, don't worry about it. I'm going to give you multiple ways to solve each of these, and whatever sticks, then just stay with that. So if I factor 76, it factors into 4 and 19. 19 is a prime number. Not that it has to be prime for it to not like continue on, but it has to not have any square numbers that it divides by. So it definitely doesn't divide by any square numbers if it's prime. So then this would be plus or minus, right? So I'm keeping the plus or minus. Square root of 4 is 2, and then root 19. Whew, that's my first answer. All right. That one is a little harder than number 2. Number 2 is going to be a little bit nicer, and you'll see why in a second. But yeah, so that's what we do. Step 1. Well, actually, you know what? As we get to harder problems, I'll show you what we did. But what we did was we basically did a square root, plus or minus, and then we simplified the square root. So I'm not going to write out the steps just yet. I will when we get to the harder problems, though, and write out exactly what we're doing overall here. Square root of both sides, it cancels out with the square. Plus or minus. The square root of 16, actually, is 4. So that's it. It has a square root, so we're done. Okay. Change color and move on. Square root, square root. That cancels. X equals. Now, 21 does have factors, but like I was saying before, it doesn't matter if it has factors if none of those factors are square numbers, right? So you would definitely help you to do these questions faster if you know a couple square numbers. Highly recommend 3 square numbers: 4, 9, and 25. If you can remember those 3 square numbers, 4, 9, and 25, and then you just look to see if you can divide by one of those 3 numbers, then that will cover like 95% of the problems. Sometimes it's a bigger square root, like a bigger number, a bigger square number that comes out, but most of the time it's going to be something that goes into 4, 9, or 25. Okay? And if you do know your squares pretty well and you're like, oh, wait, hold on, I think you skipped one, then you skipped 16. I did skip 16 because 16 is 4 times 4. 16 is like a square number. So, yeah, you could divide by 16, but you could just divide by 4 and then do it again. And that'd be the same thing. So, really just 4, 9, and 25. If it goes into 4, so here's a little trick. Here's how you want to factor these guys. If you need to simplify your radicals, if it divides by 4, then can you take half? And then if so, is that number even? Is that number even? So if you can't even take half, as in it's not an even number, if it's an odd number, it's definitely not going to divide by 4. If it's an even number, divide it by 2, as in take half of the number, and then if that number is even, then it'll divide by 4, and then you would just take half again, and then you've divided by 4. If you divide by 4, you just take half twice. Okay, so that's what you do if you divide by 4, right? If you want to see if it divides by 4. If it divides by 9, there's a nice trick to that too. You add the digits. And then that number, does that number divide by 9? Does that divide by 9? Okay, so that's how you know if it will go into 9. And then 25 is actually really easy. If it divides by 25, it has to end in 0, 0, as in like 100 or 200 or something like that. 25, 50, or 75. And that's a question mark after the 75. It has to end in one of those. It's like quarters, right? 25, 50, 75, $1. 25, 50, 75, $1. That's how quarters work as well. So, because a quarter is 25 cents. So, yeah, and that's why I would recommend these 3, is because 1, they're all square numbers, and there's more square numbers after this, but these 3 are the most often square numbers you're going to run into, and they're not that bad to figure out if they divide by another number by hand without a calculator. And then, of course, if you can use a calculator, even better, right? So let's get back to 3. 21. Does it divide by 4? No, it's not even. Okay. And then does it divide by 9? It does divide by 3. If I add 2 and 1, I get 3. 21 divides by 3, but it does not divide by 9. because 2 plus 1 is 3. 3 doesn't divide by 9. Okay? So we're done. Oh, and plus or minus. Almost forgot. Plus or minus square root of 21. We're done. That's it. Number 4, even easier. Boom, boom. A equals plus or minus 2. That's it. Square root of 4. And then add plus or minus to everything. Right? Now I'm going to start to go a little bit faster as we go along here. But that's what we're doing here. So here, we don't take the square root right away. Now that there's something else going on, we're not going to take the square root right away. And I'll show you why. It's because we want to do something called sad meg, or sad mep. We'll say sad mep for right now. Sad mep. And if you've watched some of my other videos, I have talked about this before. Sad mep or sad meg. It might look like it's kind of familiar. If you haven't used sad mep before, it probably still looks familiar. And that's because it's PEMDAS spelled backwards. PEMDAS spelled backwards is sad mep, which is like a character in a Dr. Seuss book. He's a sad mep. Oh, sad mep. So that's the order of operations when you're solving. That's the order of operations when you're solving. When you're simplifying, you're doing PEMDAS. You do parentheses first, go inside the innermost parentheses and do the math inside of there first. And then, the EMDAS, and then do the parentheses outside of that and whatever. But that's the order of operations when you're simplifying. When you're solving, you do the opposite. You go in the opposite order. So we try to subtract first if we can, and we can. X squared equals 20. Now we take the square root of both sides, because that would be an E step. We did an S step, and then we did an E step. E exponents, we did a square root. A square root is a type of exponent. Both powers and roots are exponents. Okay, so then we take the square root. Oh, and by the way, that divides by 4. It's an even number, so potentially goes into 4. Divide it by 2, take half, 10. 10 is even, so I know it divides by 4. Take half again, 5. 20 divided by 4 is 5. Or since it's a small enough number, maybe you just have that one memorized. Maybe you already knew that 4 times 5 is 20. So if that is how you did it, then awesome. Don't forget to put a plus or minus. The square root of 4 is 2, and then a root 5. Okay, so now we're going to do the same thing. We don't have anything to add or subtract, but we can divide by 2. And actually, there's not really anything we can do here. Get 72 there, but we cannot go any further because, and I went ahead and got the squared isolated, because sometimes if you have like a negative on both sides, if you see a negative, it doesn't necessarily mean game over. Get the squared term by itself first, and then if the squared term is equal to a negative, then you're done, because I can't take a square root of a negative. This number is what's called an imaginary number. Imaginary. It's imaginary, which is like the opposite of real, basically, right? Right? There's real and there's imaginary. Like literally, it's the opposite of real. But it also is literally the opposite of a real number. Literally the opposite of a real number is an imaginary number. So we're done. We can't get an imaginary number as an answer, at least not for right now. Later on, yeah. And algebra too, actually. Imaginary numbers are a thing all of a sudden. But for right now, they're not. So we would just say no solution, or I put a 0 with a slash through it, which means no solution. Or you could say no solution, so, no sol. Okay? And that's it. We would just stop there. We wouldn't have to go any further. All right? Now, here's what I was thinking about the negative thing. If I divide both sides by a negative 6, this number is no longer going to be negative. And I think that goes in, let's see. We'll just kind of divide it by hand. 41 would be just shy of 42. So that'd be 6, 36, 5, 54, 9. So we'd have 59. No, 69? Yeah, 69. Never mind. I was thinking 5, but it's 6 because it was just shy of 7. There we go. Okay. And if I multiply that out, I get 6 times 9 is 54. Here the 5, 4. And then 6 times 6, 36. 36 plus the 5, which would be 41. 414. Okay. Just wanted to double check. So now, take the square root. Well, 69 is odd, so it's not going to divide by 4. It's not going to divide by 9 either. It looks like it might, but 6 plus 9 is 15. 15 does not divide by 9. It divides by 3, so it goes into 3, but it doesn't divide by 9. And it also doesn't end in 25, 50, 75, or $1. So we're good here. We're actually done. M is equal to plus or minus the square root of 69. You just leave it alone. It doesn't divide by any square numbers. So we're done. Okay, now, if we divide by 7, get negative 3. Here's where it's negative, right? So on number 7, it was equal to a negative, but the left side was negative as well. So when we divided by a negative, it became a positive, and we could solve number 7. Number 8, we can't because not both sides are negative. So just wait. If you want to be really careful, just wait till you get the squared term by itself, and then if it's still equal to a negative at that point, then it's no solution. All right, moving on. So in here, minus 7, boom, boom, m squared equal to 81. Oh, that worked out really nicely. Square root of 81 is 9. M is equal to plus or minus 9. All right. Now we divide by negative 5. Negative 5. X squared equal to 100. That one worked out well, too. Look at that. They're being nice to us for a little bit here. Almost forgot the plus or minus. Plus or minus 10. All right. Yeah, we can do plenty of those. Keep up the easy ones. Let's see. Negative 7. N squared equal to, let's see. 44. That would go in. 42 would be 6. 42 is only 2 away. 228. 28 would be 4. 64. Ooh, that has a nice square root as well. Plus or minus 8. All right. We divide by negative 2. Negative 2. Remember, you're going to save the exponent to last because E is one of the last letters in SAD MEP. So you do that thing last. Unless there's a parentheses. And then whatever's inside the parentheses, you would do last. Looks like 81 again. So we take the square root. K is equal to plus or minus 9. All right. Minus 5, so we do add 5. Squared is equal to 78. And 78 add 2, you'd get to 80. 80 divides by 4. So that means 78 is not going to divide by 4. If I have to add 2 to a number to make it divide by 4, then that number doesn't divide by 4. That's another trick you can do. Or you can take half, and half would be kind of hard, but you could do it. It'd be 39, and then that's odd, so it wouldn't work. So it doesn't divide by 4. 7 plus 8 is 15. That doesn't divide by 9. It doesn't end in 25, 50, or 75. So x is just equal to plus or minus the square root of 78. And that's it for that one. Okay, 16. Ooh, that's not going to go in evenly. 49 is 7 times 7. 16 is 4 times 4. They don't divide. The fraction doesn't divide. This is the first time we've had a fraction. But you know what? It's okay because if I take the square root of a number that's a fraction, you could turn it into a decimal if you wanted to, especially if you're using a calculator. As long as your teacher's okay with you using a calculator, then just use the calculator and you can tell the calculator to take the square root and spit out the answer. That'd be fine. If you can't use a calculator, this is what you would do. You take the square root of the top. The square root of 49 is 7. The square root of 16 is 4. And then plus or minus. See, that wasn't that bad. Take the square root of the top, square root of the bottom. and you do them separately. Okay, we're halfway there, and we're speeding up as we go here. So we add 5. N squared is equal to 1. And there we go. N is equal to plus or minus 1, because the square root of 1 is 1. Minus 8, minus 8. N squared is equal to 72. Square root, square root. 72 actually divides by quite a few things. It divides by 4. It's going to go into 4 because if I add 8, I get back to 80. If you add any multiple of 4 to a number and it gets to a number that's still a multiple of 4, then that number is a multiple of 4. It's a little trick. Or you can take half and then take half again. Half of 72 is 36, and then half of that is 18. So 18, and then that divides by 9 and 2. It divides by 9. 1 plus 8 is 9. 9 divides by 9. And then we get that, and that, and that. Because, 18 broke down. So we don't include the 18. So we get the square root of 4, actually plus or minus, right? So plus or minus. Square root of 4 is 2. Square root of 9 is 3. And the square root of 2 is the square root of 2. So all together we get plus or minus 6 root 2. Okay, so that was a little bit of a longer way to do it. I mean, obviously, it's a way that works pretty well. I think it works pretty well, but it's like a beginner to intermediate level. So if you feel like you're starting to get pretty good at this stuff, I would challenge you to just look for the square number. Memorize the square numbers up to at least 10. So 4, 9, 16, 25, 36, 49, 64, 81, and 100. I had to think about the last couple and make sure I didn't miss any. Make sure you have some of your square numbers memorized if you want to get really good at this. And then just try to divide the number by the biggest square number you can. That would eventually be the best way to do it. So I was thinking that as I was going, I was like, oh, 72 divides by 36. But I wanted to keep with the same method to show you that same method. But I'll start to do it a little bit faster as we start to round off these last few problems here. So now we've got a few steps. But remember, we want to do SAD MEP. We want to subtract first. All right. Then we divide. Divide by 7. V squared equal to 4. Then we do exponents. All right. Now that we've got 3 operations we have to do, we have to keep our ducks in a row here. V is equal to plus or minus 2. So that worked out pretty well. But just be careful. You want to make sure you're doing your operations in the right order. You want to do adding or subtracting first, then dividing and multiplying, then exponents. You can switch the order with the adding and subtracting because they're kind of the same thing, and the dividing and multiplying because they're kind of the same thing. But adding, subtracting, then dividing and multiplying, then exponents, then a parentheses if you have a parentheses. Okay, so minus 2. N squared is equal to 290. Divide by 10. 29 is a prime number, so we're done. There we go. Okay, next. We're gonna do minus. And I'm going to stop showing the intermediate steps here. I've already started to kind of slow down on the intermediate steps as we start to go a little faster and faster, and I'm writing and talking at the same time. Sometimes I really can't multitask. Divide by 2. Take the square root. Plus or minus 10. All right. And we do it again. So, minus 10. If we're going to subtract 10, we get 81. Then we divide by 9. Then we take the square root. Plus or minus 3. Bing, bang, boom. Okay. Then we have add 7. Oh, I said I wasn't going to do the intermediate steps, but this one's a little bit tougher. 4, 8, 8, 8 plus 7 is 15, so that's 495. Then we divide by 5. If I add 5, it's 500. 500 divided by 5 is 100, so this would be 99. And if we multiply it back out, it should work. 9 times 5 is 45. And then 9 plus 5 again is 45. 45 plus 4 would be 49. 495. Square root, square root. I can divide that by 9. So this is going to be, if I divide it, I would get 9 times 11. The square root of 9 is 3, so plus or minus, right? Plus or minus, the square root of 9 is 3. And then I have the square root of 11. All right? We are getting to the last part here, so I'm starting to go a little bit faster, not showing as much of my intermediate steps. One, because of space issues, and then also to show you what it looks like when you start to get the hang of this, what it should look like, okay? Plus 6 plus 6. I keep doing the intermediate step right there for some reason. I don't know why. Old habits die hard, I guess. 312. That does look like it divides by 8. Let's see. 32 would go in, so it's a little shy of that. So it'd be 3, 24. 24, so it'd be 7. 72 would be 9. And that's it for that. It wouldn't go any further, so 39 would just be 13 and 3. So we'd be done there. Okay. Let's go back to Indigo. Indiegogo. And, okay, so then we have 10n squared equal to 480. Then we divide by 10. And that goes into 4. Goes into 4, and then I'd have 12 left. So it actually goes into 16. 16 and 3, so that would be 4 root 3. Okay. 8n squared equal to, I'm going to add 4, 5, 3, 6. Then I'm going to divide by 8. I think that divides by 8. Let's see, 250, 265, 268, 268 goes into halves pretty well, actually. 268 would be 1, 3, 4, and then that's still even. So 1, 3, 4, we'd have 50, 15, 65, 67, 68, 69. Ooh, okay, I kind of want to check that one on a calculator, because I feel like I held on to those numbers pretty well in my head, but if I was on a test, I probably wouldn't have done that in my head. Oh, no, I was off by a little bit. 67. I did not hold those numbers in my head well enough all the way to the end. So 67 on that one, not 69. Okay. Then we take the square root. I think 67 is prime. Wouldn't go into 4. It wouldn't go into 9. And it wouldn't go into, yeah. So that's it doesn't even matter if it's prime. If it doesn't go into 4, 9, and 25, and it's not a really, really big number, then we can just stop there. N equal to plus or minus 67. Whew. Okay. So, next up, we've got 4r squared equal to, subtract 1, 3, 2, 4. That goes into 4. Let's see, that'd be 150, 162, and then 81. So r is equal to 9, plus or minus. There we go. Here we add 7, so that's 200. Half is 100, half 50, half 25. They're giving us nice numbers again all of a sudden. It's kind of weird. Almost makes you like second guess what you were doing earlier that was harder. Like number 24, I almost want to check on number 24 now and see if I got that right. Because it's like, wow, like hold on. Why is it so easy now all of a sudden? Because it's the same stuff. It's like 3 steps. All right, I believe that's a minus, so we want to add that. So we add that, 146. Divide by 2, 73. And that's not going to divide by anything, so k is equal to plus or minus square root of 73. All right, and then here, oh, it's a little backwards. Let's see here. So minus 3 on both sides, because 3 is positive. Even though it's 3 minus, the 3 is positive, so we subtract 3 on both sides. If I subtract 3 from a negative, though, I add them. Whew, negative 88. Then I divide by negative 4 on both sides. If I take half, I get 44. Take half, 22. Positive 22. And square root, and then I'm actually done, because that doesn't really divide by anything. Any square numbers, that is. Plus or minus square root of 22. All right, and that was it for today. So if you thought that was helpful and you want to see other awesome resources, you can check out my website, Myers Mathematics. And if you want to shoot me an email, let me know how I did here. If I missed anything, you can put it in the comments, or you can shoot me an email. Or if you're interested in tutoring, shoot me an email. All of that is in the comments, in the comment section, or the description, I should say, below. But that is it for today. So awesome, and I will see you guys next